Oh yeah, how are we doing? Thanks a lot for waiting. Sorry, a little bit late. So this is today's daily revision question, and then I'll go through some of the answers from yesterday's. A student notices two different plugs in their house. One has a plastic pin. This one is a plastic pin, but the other one has a metal pin. Why the difference, basically, is the question. I want to just get this word for word, and I'll put this is already in the description, and I will put it in the comments as well. Leave your answers to this one. This is a revision question. Leave your answers to it in the comments below. So a student notices the differences between two UK mains plugs. One has 3 metal pins and the other has one plastic one. They also notice the symbol, a square within a square, and I'll show that to the camera in a minute. Describe the UK mains electricity system and explain the action of the safety features in it to keep the users safe. Explain why one plug requires 3 metal pins and another only 2. And then there's some bonus details, especially if you're an A-level student, then this will be an important one for you. Discuss the RMS values in mains electricity. Ignore that if you're a GCSE student. And explain in detail the actions of the fuse. So there's a couple more detailed, and then I'll go into answers from the last one. The camera, I don't know whether the camera is really going to manage to see this, but there is a little square within a square, probably can't focus that, on this plug here, the one with the plastic pin. What is that? What does that mean? And this one also has the fuse exposed there. You can see this is a 5 amp fuse. So what's in detail, how does the fuse work? So not just basically how it works, in detail, how does it work? Think about your A-level detail. I'll say that question again. It's also written in the description, and I'll also put it in the comments as well. And leave your answer in the comments. There were some really excellent ones in the comments. Some other people chose to email me some ideas. Maybe they weren't confident to put it out there in the comments, which is absolutely fine if you want to do that. But they were good answers, so be confident and go ahead and share your ideas in the comments box there. And I'll pick out some GCSE examples and some A-level examples of some good ones. First of all, the last question was all about energy transfers in braking, okay? And firstly, look at the clues. Look at the clues and the way they've written the question. And they actually said in that question, use ideas about energy stores and transfers. So really, whenever we're thinking about energy stores and transfers, guys, I want you always to think about the one store decreasing, the transfer, and another store increasing. So identify firstly what store has decreased, and in this case it was the kinetic store of the vehicles. That's decreasing. The transfer is mechanically transferred, so it's work done. Mechanical work is being done, and that's by friction of the brakes. And the thermal store of the brakes or the surroundings as well, are increasing. That's the one that people didn't get. They talked about the kinetic store decreasing, and they actually calculated values for the kinetic store, which is brilliant. They didn't talk about the thermal store, which is what I would have wanted to have read more about. Rachel Burnett Music, though, did talk about the thermal store increasing, so that's fantastic. So I thought that was a really good example. That was probably the best example of talking about one store decreasing, a mechanical transfer, another store increasing. So just think about that. Starting store, transfer, final store. And also, if they're saying use ideas about energy stores and transfer, get in the law of conservation of energy, is that energy cannot be created or destroyed, just transferred from one store to another. So get that word in there, or at least say the decrease in this store is equal to the increase in this store. That is the law of conservation of energy, and it's a crucial thing for the new kind of paradigm, the way we explain energy. There were some other really good things. I did say in the question, estimate some typical values and calculate in your answer. And loads of people estimate a typical mass of a car around 1,500 kilograms. Typical mass of a lorry somewhere between 5 and 10,000 kilograms, and use that with a typical speed. And you had to convert from, if you know a typical speed of something might be 60 miles an hour, convert from miles an hour into meters per second. And the way to do that is it's either times by 1,700, which is meters in a mile, and then divide by 3,600, which is seconds in an hour, or it's just divide by 2.2. A rough rule of thumb, miles per hour is roughly double meters per second, so 60 miles an hour is roughly 30 meters per second. Okay, but there were some sensible estimations and some good calculations for kinetic energy. One that was really, really good Human snake actually worked out the power of the brakes, which is a really clever way to do it. What you could then do, though, if you've got kinetic energy, you can make that equal to the work done. So you could estimate a distance that they brake over, and that would give you a force, a braking force. Or you could say that's equal to the thermal energy increase in the brakes. And then you could talk about the materials of the brakes, maybe the specific heat capacity of the material that you're making out of, or just having larger actual disc masses so that they can dissipate more thermal energy, or maybe just larger areas of brakes so that you get more friction, so you can actually stop the things over a shorter distance. Lane, I thought, gave some really interesting detailed stuff I didn't know, which was this pneumatic versus hydraulic. So lorries, HGVs apparently have pneumatic brakes rather than hydraulic brakes. I didn't know this, to give them that extra force. Maybe they have like different systems, but I certainly do know this, that lorries, HGVs, and trains and other very large vehicles have what we call electromagnetic braking systems. And that is very, very useful because you don't get friction, and therefore you don't get such a large heating effect, and therefore you don't get what's called brake fade. And brake fade is where the discs actually heat up so much that the surface of them starts to melt, and then you get this kind of lubrication effect, and you can imagine then you don't get a lot of friction, and the brakes don't work as well. And especially important when that's especially important when lorries and things are going downhill, because you don't want to get brake fade when you're going down the hills, obviously. And so they use these electromagnetic brakes, these eddy current brakes, to make sure that they're kind of the braking systems are working well throughout that. I'll have a look at the chat just in a little bit later, because there's a couple of people just popping up there. I think that's about it, but there's been absolutely great stuff there. Human Snake also gave some great ideas of different situations. For example, lorries on icy roads, uphills and downhills. How when you're going uphill, then you have less of the actual gravity itself is kind of braking force, slowing the vehicle down. So that was an interesting point that Human Snake made. Okay, that's about it really. So I would just say, add to that, make sure you make that point about the starting energy equaling the final energy, that law of conservation of energy, and use energy to make calculations. So if you can calculate a kinetic energy first, what can you use in a new calculation? You can calculate thermal energy, work out how a specific heat capacity of material might affect it, or how a temperature change might affect it, how hot the actual brakes might get, or something like that. Okay, let's leave that there then. Let's repeat this new question today, and have a go at that in the comments. Be really confident about your answers, because you give really good answers. What I'm trying to do with these is I'm trying not just to do GCSE or A-level ones. What I'm trying to do is that you do, I'm trying to do ones that are good revision for everyone. So they're going to touch on ideas, and yet either kind of GCSE level or an A-level level, and I will give you marks for I'll pick out a good example of A-level, and I'll pick out a good example of a GCSE one. So this question is all about these two plugs. So a student notices that two UK mains plugs, one has 3 metal pins and another has 2 metal pins and a plastic one. So the question is, describe the UK main system. So that's quite a GCSE point, so maybe skip that if you like. But for A-level, you can go into the idea of RMS voltage and other things like that as well. And it's still an interesting point, isn't it, why these pins are different. Anyway, crack on with the question itself. Describe the UK mains electricity supply and explain the action in the safety features in keeping the users safe. Explain why one plug requires 3 metal pins and the other only needs 2. And the bonus ideas discuss the RMS values of mains electricity and explain in detail the action of the fuse. And that's when your A-level stuff's going to come in there. You could even use those RMS values to make typical examples. Think about what's going to happen if somebody does get connected into the circuit. What typical kind of powers are they going to get? How that's going to cause them damage. There's loads of scope to take that question into an A-level standard. So these questions, they're not exam questions that I'm trying to give you. I'm trying to give you revision questions just to make your revision that little bit more targeted, so you can think around that idea. Hope that helps, Lane. All right, this stream is available. It's available now for forever, Chris, so I hope that helps. As I said, Somebody asked for Aliyah Rashid asked for full exam playlists, but I've got loads, mate. So I don't worry about that. If you look at last week, I did some GCSE questions, and I have full exam playlists that I go through question by question, all of set exams. Go ahead and find those. There's loads and loads and loads of questions out there that you can try. This one is to get you thinking about it. Leave your ideas down in the comments. Okay, and tomorrow I'll be back with picking out some answers to that. You can also go back to yesterday's video, and you can go ahead and look over the answers that people did give, and I've left some useful constructive comments to that. I will give notes that I've just made on those questions on the comments from yesterday's video as well. Andrew asks, could you have calculated thermal energy? Yep, absolutely. Well, so what we're saying is that the kinetic energy will be transferred into thermal. You would have had to make some assumption on the specific heat capacity of the pads, yeah? Well, the pads, I believe, are all going to be steel. Well, I know they're all going to be steel because sometimes your brake pads rust. I don't know if you've ever seen that. So the specific heat capacity of steel is about 500 joules per kilogram per degree C, and therefore you could work out, you can estimate the mass of those in the order of maybe 5 kilograms or something like that, and you could work out the temperature rise in those. You could then find out whether that was going to be close to the melting point of steel. That would be an interesting thing. That would give you an idea of whether or not they were going to get that break fade, whether you're going to get that melting effect. So there's some interesting things to that. You could look at, sports cars brakes, which are ceramics. What do they have, a lower specific heat capacity, or do they just have a really high melting point so they can get to real high temperatures, so they can dissipate that heat energy because they get to high temperatures, or do they dissipate the heat energy because they have lower specific heat capacities? Find that out. That's the type of thing for revision, is not an exam. If they needed you to go into that detail in an exam, then yeah, they'd have to give you those numbers, wouldn't they, to do those calculations. But with revision, then you can go ahead and you can take your time to get involved with a question like that. Can I explain the national grid? Well, in very short terms, then you have a power station that gives out the electricity at a low voltage, or lowish, it's like 30,000 volts. Then a step-up transformer, so you get real high voltage in the power lines, but crucially a low current. So you get less power loss in the power lines, because power loss is I squared R, half the current, quarter the power loss. And then you have a step down transformer to make it back to a safe voltage for our homes. I have got some national grid videos as well. I generally forgot most of the stuff I learned early in the year. Yeah, I know, that's the thing. That's why going through these revision questions can lead you down lots of ways. And the interesting thing about your answers, Lane, was you found things that other people didn't find, or I didn't think of that question. So me asking you that question got you to look up some different physics, which I hope was some interesting physics, and maybe revise some of those things that you hadn't looked at for a little while. And lastly, just with Andrew, would that have been a 6 pointer? And what points would you give the 6 points? Yeah, pretty. That I wrote that to be kind of like a 6 marker. So for the 6 marks, would have been firstly for probably a 2 mark question. The 2 mark answer would just be getting the idea that the kinetic energy is dissipated into the thermal store. So kinetic energy decreases, thermal store increases. Maybe the idea that the lorry has a larger kinetic store at the start, so a larger thermal store at the end, that type of thing. For saying the mechanical transfer by friction is probably going to be into the kind of 3 or 4 marks now. Actually doing that calculation, so making the estimations, would have been a 3 or 4 mark as well. Adding that in there, having some idea of that being transferred into another form and being able to do a calculation with that, or at least hint at some way of calculating with that, would have been the 5 and kind of 6 mark there. So really the detail is kind of describe the energy transfers, make estimations and do calculations, and then compare, crucially, for the 5 marks and the 6 marks, Andrew. I hope that helps. And really, whenever you're doing those 5 or whenever you're doing those 6 marks, whenever you're doing any longer written question, make sure you look at the clues and look to check you've done everything that they say that you need to. Okay. Let's see. The star, much bigger than the sun, once the star reached the end of its main sequence period of its life. I did stellar evolution like twice in the last live feed, so I'm gonna go and ask you to live feeds that I did just recently. Is a good question. Simply put, it's going to go to a red supergiant, so it's going to expand and cool. It's going to then go supernova, and then after that, it's going to either become a neutron star or a black hole. Now, it's the processes in between those that are going to get you the kind of 6 marks, rather than just knowing the names of different things for the life cycle of stars. So there's loads of stuff on the stars on my channel if you just go and have a little look on that. All right, I'm going to say thanks and bye. That question from today, it's in the description, and I've said it a couple of times. Basically, why one of these has a plastic pin, and I'm being careful not to tell you things like tell you the name of that, because that might get you the things. Why this has got that little symbol on it, the little double square, and I'm being careful not to tell you the name of that, because that might be part of the mark scheme. And why this one needs 3 metal pins, and the action of these fuses and the other safety features. Okay, dudes.